Good day, my scholars. You're welcome to my school channel, and my name is Abiola. Do not forget, in this channel we are solving the JAMB CBT past question for the subject chemistry, the year 2014. Don't go anywhere. Stay with us, and we'll be right back. You're welcome back to my school channel, and in this video segment we are solving questions 1 to 15. So let's begin with question 1. A mixture is different from a compound because what? So what we are required to do is to validate or invalidate statements. Okay, so we have statement A. The properties of a compound are those of its individual constituents, while those of a mixture differ from its constituents. Okay, this is incorrect because this is a kind of a mix up. There's an interchange. Okay, whatever description we have here, all right, that is the description that fits for compound. Whatever description you have from here to here, that is the description that fits for mixture. So statement A is invalid. All right, so let's look at statement B. A mixture is always homogeneous while a compound is not. Okay, that is incorrect. Okay, we know that compounds are always homogeneous. Why a mixture can be homogeneous or heterogeneous. So B, invalidated. So let's look at statement C. The constituents of a compound are chemically bound together, while those of a mixture are not. That is correct. Okay, that is very, very correct. Let's look at statement D. A mixture can be represented by a chemical formula, while a compound cannot. Okay, that is incorrect. That's actually an interchange. We can represent a compound by a chemical formula, while a mixture we cannot. All right, so the correct option here is option C. The constituents of a compound are chemically bound together, while those of a mixture are not. Okay, of a mixture are not. So once again, option C is very correct. Number 2. What is the percentage of sulfur in sulfur 4 oxides? Okay, so recall that sulfur 4 oxide has the chemical formula SO2. So we are asked to look for the percentage of sulfur in sulfur 4 oxide. Okay, so remember, atomic mass of sulfur is 32. Okay, plus, we know oxygen, that's 16. We have 2 of it, right? So that is 32 plus 32. That is 64. So we can now tell, okay, the mass of SO2 is 64, isn't it? So that will be, how many sulfur do we have in it? We have 32 of it in 64 times 100%, isn't it? So 32 here 1, 32 here 2, 2 here 1, 2 here 50. So 50 times 1, that is 50. So we can see that sulfur actually occupies, or it's about 50%, okay? It's 50% of the compound SO2. So let's go back to the board to sort out the correct option. So which of the options carry the value 50%? That is option D. So the percentage of sulfur in sulfur 4 oxide is 50%. Option D is very correct. Question 3. A gas X diffuses twice as fast as gas Y. Okay, so if the relative molecular mass of X is 32, calculate the relative molecular mass of gas Y. So we just have to go into this formula. Okay, so which is the rate of diffusion of gas Y over rate of diffusion of gas X, right, equals this. The molecular mass of gas X over the molecular mass of gas Y. Their square roots. Okay, so we are told that this diffuses. Okay, let me read out the question again. Gas X diffuses twice as fast as gas Y. So that will be 1 over 2 twice. Okay, equals molecular mass of X is given as 32 over unknown molecular mass of gas Y. So what do we do to remove this square root? We square both sides, right? Isn't it? So square strikes out square root. 1 raised to power 2, that is 1 times 1, that is still 1. So we have 1 over 2 raised to power 2, that is 2 times 2, that is 4, equals 32 over molecular mass of gas Y. What do? We cross multiply. So that will be My times 1, that is still My, equals 32 times 4. All right, 4 times 2, that is 8. 4 times 3, that is 12. So our answer is 128. So let's go back to the screen to sort out the option that carried the value 128. So which of them carries that value? That is option A. So option A is very correct. Number 4. 200 centimeter cube of a gas at 25 degrees Celsius exerts a pressure of 700 millimeter mercury. Calculate its pressure if its volume increases, okay, to 350 centimeter cube at 75 degrees Celsius. Okay, so we just have to use the general gas equation. Remember, P1 V1 over T1 equals P2 V2 over T2. So we are asked to look for P2. All right, so we are going to have P2 V2, right? T1 equals P1 V1 T2. What do? Divide both sides by V2 T1, V2 T1. Okay, so that will be P2 equals P1 V1 T2 over V2 T1. Okay, so from the question we are told that V1 is 700. Then P1 is 700, V1 is 200. Okay, T2 is given as 75, but we have to convert it to the Kelvin scale. So that is 75 plus 273. This is 8, right? This is 4. Lift 1, that is 348. All right, so V2 from the question, V2 is given as 350 times T1, okay? T1 is given as 25. So 25 plus 273. Okay, 8, this is 9, this is 298. All right, so this goes here 2. By the time we multiply, all right, and we do all of the division, multiplication together, we should have roughly 467.1 something. Yeah, there about 4. Now we're actually looking for pressure. So the unit we'll be using so far is millimeter mercury. So we'll just watch out for something around 467 in the options provided. So let's go back to the screen and see if we can find something around that value. Okay. So if you look through the options provided, you will find the correct option as option C, 467.11 millimeter mercury. Do not forget to get any of the Myschool tools, either the Myschool mobile app or the Myschool software. All you need to do, use that link in the description below. Clicking on it takes you to the Myschool website where you have access to download any of these tools. So join me as we solve question 5. An element X has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Which of the following statements is correct about the element? Okay, so at first, let's determine the atomic number of that element. So this is 2 plus 2, that is 4, plus 6, that is 10, plus 2, that is 12, plus 5, that is 17. So what element has the atomic number 17? That element is chlorine. So definitely we know that chlorine belongs to the group 7. Those are halogens. Okay, they are all non-methyls and they are the most reactive non-methyls. Okay, and also they are diatomic in nature. As well, halogens are known as salt formers. So practically, even without going through the options, I can tell that the element is chlorine. Okay, it belongs to the halogen family, group 7. So let's scan through the options provided and see if the solution we've provided is not out of context. A, it has a completely filled p orbital. That is incorrect. The p orbital is not completely filled, okay, if you try doing the filling. All right, so we have statement B. It has 5 electrons in its atom shell. That is incorrect. We know that chlorine is 287. So there are 7 electrons in the outermost shell, remaining 1 for it to complete. Okay, so it belongs to the group 2 on the periodic table. That is incorrect. Okay, element that belongs to the group 2 in the periodic table actually have 2 electrons in their outermost shell. For example, calcium, magnesium. Okay, so V, it is an halogen. It is a halogen. Of course, we confirm that the elements chlorine, which is element X that we have identified, is halogen. So option D is very correct. Do not forget to hit that like button. Also, click on the subscribe button and always tap on bell notifications so you can get alerts immediately we upload the next video clip just for you. Question 6. Beryllium and aluminium have similar properties because what? Okay, the most viable presentation here is because they are positioned diagonally to each other. You know, metallic characteristics, it increases down the group and decreases across the period from left to right. So you can notice this diagonal relationship between lithium and magnesium, then beryllium and aluminium. Okay, so that is one key thing that we should take note of. Truly, they are both metals, but it is not as viable as the presentation we have here. Okay, let's examine statement B. Statement B says they belong to the same group. That is incorrect. We know that beryllium, atomic number 4, hydrogen, helium, lithium, beryllium. So configuration 2, beryllium has 2 electrons in its outermost shell. That means it belongs to group 2. Okay, aluminium is 2A3. Okay, that means it has 3 electrons in its outermost shell. That tells you aluminium belongs to group 3. So that marks them. That marks the statement invalid. Statement B. Let's examine statement C. Belong to the same period. That is also incorrect. Beryllium has 2 shells, so period determines the number of shells. At least you can use that presentation. So beryllium has 2 shells, okay, 2 innermost and 2 outermost. Why for aluminium it has 3, okay, 2, 8, 3. The first 2 is filled. The first shell is filled. The second shell contains 8 electrons. It is filled. The last shell contains 3 electrons, trivalent. So they do not belong to the same group or the same period. So the most viable option here is option D, is because they are positioned diagonally to each other. So option D is very correct. Question 7. If the difference in electronegativity of elements P and Q is 3.0, the bond that will be formed between them is what? Okay, so we can use these values I'm going to present, although it's subjective, okay, based on different presentations. Okay, so when we talk about electronegativity of an atom, you know, in a molecule, is the power of that atom to attract electrons. So when you look at this simple scale, we say from less than 0.4, that tells you a non-polar covalent kind of bond. Okay, from that 0.4 to 1.8, okay, you are talking about a polar covalent type of bond. Then from the 1.8 upwards, we are talking about ionic type of bond. Okay, so some put it at 1.7, some put it at 1.9, but what have you? So the correct or most viable option to this question is option D for ionic type of bond. Number 8. So how many protons, neutrons, and electrons respectively are present in the element 6027? That's for cobalt. Okay, so the 60 is a superscript, the 27 is a subscript. Okay, superscript, subscript. So the superscript tells us about the mass number of that particular element. And mass number is a combo between the atomic number or the proton number and neutron number. So that means we've gotten the proton number as 27, right? So proton number is 27. So we can see that 27 plus 33 gives us the 60. So that is addition of proton number plus neutron number. That gives us the atomic mass. So we can see that the proton number is 27, neutron number is 33, right? And the electron number is 27, okay? So the correct option now should be 27, 33, 27. So where do we find that? That is found in option C. So once again, option C is the correct option. Question 9. The radioactive radiation used in studying the arrangement of particles in giant molecules like protein, okay, or arrangement of particles in a crystal lattice, that is X-rays, okay. Talking about gamma radiation, you can use it to sterilize medical equipment, surgical equipment to be precise. And then also you can use to destroy cancerous cells. All right, talking about beta particles and alpha radiations. We can also use them to control, okay, or measure the thickness of sheet materials, filling of packets, and what have you. So the correct option here is option C for X-rays. Do not forget to use that link in the description below. You need to do. Click on it. You are going to be moved to the Myschool website where you encounter our solution providers, and then you can ask your questions. So join me as we solve question 10. A silicon containing ore has 92% and 28 silicon. All right, we have 5% 29 silicon, 3% 30% silicon. Okay, calculate the relative atomic mass of silicon. Okay, so the relative atomic mass, we just have this presentation, the percentage for that isotope times the mass. Okay, so the first one we are given 92% and 28, so that will be 92 over 100, right? Okay, times 28. We add it up. Right, the next isotope we have 5% and 29 is 5 over 100 times 29. Okay, so then the last we have 3% and 30. Okay, so we can decide to work around these values. By the time we multiply, then we'll divide by 100. We multiply, we divide by 100. We multiply, divide by 100. Okay, then we add up all of the values gotten. What we should have roughly, I'm doing this to shorten the video length, okay, should be 28.11. Thereabouts, yes, 28.11. So join me, let's go back to the screen to pull out the correct option. Remember, you have to go through this video clip if need be, okay, so that you can have clarity and better understanding of the process. So where do we find that? That is option C. So option C is the correct option. Perhaps you have better steps, explanations, or contributions you'd like to share. Please, we are very interested. All you need to do is to use the comment section below, indicate that question number and the explanations or contributions you'd like to share. 11. Water is said to be temporarily hard when it contains what? Okay, so talking about water, we have the soft water and the hard water. So the hard water now, we have the temporary hardness and the permanent hardness. Temporary hardness, we are talking about calcium and magnesium ions, okay, in form of soluble tetrasulfate 6 and chlorides. Why for the temporary hardness, which we are required, okay, to provide answer for, is caused by the presence of calcium hydrogen triiodocarbonate 4. Okay, which decomposes on heating to give us this calcium triiodocarbonate. This. So the correct option here is option B, this and this. So it is temporary hardness is caused by the presence of this, okay, which decomposes on heating to give you this. So the correct option here is option B. Question 12. On exposure to the atmosphere, a hydrated salt loses its water of crystallization to become anhydrous. Okay, this phenomenon is referred to as what? That is efflorescence. Example is a global salt. Okay, when you talk about deliquescence, when exposed, all right, it absorbs water, then it forms a solution. Okay, for example, your potassium hydroxide. And when you talk about hygroscopy, it actually absorbs water. Then it doesn't turn to moist. It doesn't turn to solution. Okay, it can become sticky. All right. Then talk about hydrolysis is one way whereby you can obtain glucose. Okay, you talk about hydrolysis of starch with dilute acid to get glucose. So the correct option here is option A for efflorescence. 13. 16.55 gram of lead 2 triazonitrate 5 was dissolved in 100 grams of distilled water at 20 degrees Celsius rather. Calculate the solubility of the solutes in mole per dm cube. So at first we have to get the molar mass of this. Okay, but first just remember this, we have PB, right? This is lead 2 triazonitrate 5, right? This is the formula for it. So remember that lead is 207 into brackets, right? We're adding it up. So this plus nitrogen is 14, right? Plus oxygen is how many? Oxygen is 16, but we have 3 atoms. So 16 times 3, that gives us 48, okay, into bracket 2. So I have 207 plus 14 plus 48, okay, that should give us 62. So 62 times 2. So that will be 207 plus 2 times 2, that is 4. 2 times 6, that is 12. So 207 plus 1 to 4, that should give us, this is 1, carry 1, that is 3, then 3. So we have 331. So recall that molar mass, right, equals, what's the unit for molar mass? That is gram per mole. So molar mass equals mass over mole. But this time around, we are asked to look for, we are going to sort out for mole, okay? So that will be, mole will be equals to mass over molar mass, okay? So that mole will now be equals to, what is the mass? 16.55 from the question, right? The molar mass we've gotten is 331. When we divide, we should have roughly 0.05. So we can now say that 0.05, talk about 100 grams of water, isn't it? That's correct. Then, how much quantity are we looking at in 1,000? Okay, so by the time we cross multiply, this comes here. So we have 0.05 times 1,000, right, equals x times 100. Dividing both sides by 100. Okay, so 0.05 times 10, that is 0.5. So this is the value we are looking for. So let's go back to the screen if we can sort out this value. Okay, so 16.55 gram of lead 2,935 was dissolved in 100 gram of distilled water at 20 degrees Celsius. Calculate the solubility of the solute in mole per dm cube. So the solubility of the solute is 0.50 grams. So the correct option here is option D. Question 14. The dispersion of a liquid in a liquid medium will give you what? Okay, so just go for the definition or check out for the definition of emulsion, and this give you a very beautiful description. So the correct option here is option A and emulsion. Question 15. The major and the most effective way of controlling pollution is to do what? Okay, so this tells us that all of the options provided, they are very effective ways. Okay, so but the most and the major effective way is what? Okay, so this is a very subjective presentation. Okay, so I'm just going to offer my mindset or perception about the correct option. So let's look at option A. One way is to improve machinery so that the substances released from combustion are less harmful. Of course, this is very effective, okay? But talk about maintenance culture. If the machines are well produced or well packaged and usage or maintenance is poor, definitely whatever that will be coming out from the machine, okay, either through combustion, either through activities that the machine is doing, can lead to production of pollution or pollution, whatever. So we can say it still boils down to the individuals, okay, operating the machines, okay. So I'm not saying option A is not valid, but in my own view, is not strong enough, is not the most effective. So let's look at option B. There should be passage of strict laws against it by individuals and companies. Of course, when policies or laws are being initiated against pollution, you will still find out that a good number of people will comply, okay, due to the strictness of the law, but somehow they can maneuver, all right, when the law is not watching or when the law cannot reach, okay, they still have their way of introducing this pollution to the environment, okay. So it is very good, but for me, not the most effective. Okay, let's look at option C, educate people on the causes and effects of pollution. Okay, so this looks most appealing to me because all of this boils down to activities of humans. Okay, so when people are educated about the causes, what actually leads to pollution, it shouldn't even be only machines. Okay, there can be other activities that humans do that contribute to pollution. So once men or humans generally are able to be educated. They are being educated on what causes pollution and the effect it has on their environment, on their health, on the next generation, and on the planet Earth. Okay, it's going to cause a shift in their attitude towards pollution. Okay, managing it, in controlling it, in reducing it, and whatsoever. So option C is most viable and most appealing to me. I have sentiment for option C. So let's look at option D. Convert chemical waste to harmless substance before releasing them into the environment. Of course, this is a very effective way as well, but this all boils down to the humans carrying out this activity. So all of these, they are subjective to the attitude of the mindset or perspective of humans assigned or required to carry this out. So the most viable option for me, the major and the most effective way of controlling pollution is to educate people on the causes and effects of pollution. So option C is viable, most viable. We've come to the end of this video segment, but there are more video clips to come. All you need to do is to click that like button, also on the subscribe button, and always tap on bell notifications so you can get alerts immediately we upload the next video clip, all for you.